Alright, okay, here we are on our 13th lesson on our Just the Math series, which is which is also the first chapter. This is chapter 4. Alright, this is chapter 4, and this is the very first lesson of chapter 4. So now we will talk about the common logarithms. Now, you may think that the word logarithm sounds so intimidating, but no, don't worry. And our goal by the end of this video is to understand what are they, how they work, and how we can use it. Okay, and yeah. So before we start, this is a usual thing we do in our lessons, that we must have a review from the last lesson. So a quick review. So we have here the radical sign, which is we are also and some it is also called as a third, but most commonly it is called radical. So it looks like damn it looks like this symbol right here. All right. So it is it represents a square root of a number, or specifically the positive or principal square root. Like for example, we have the square root of 16. That's the answer. The answer is 4. Or the square root of 25. The answer is 5. So like in these examples, the number under the radical is called the radicand, like for example the 16 and the 25, right? So like this knowledge is essential because square roots are like the inverse of squaring a number. So that's just like the logarithms that we're gonna talk today, so which is the inverse of exponentation. So like these inverse operations help us to unravel equations and understand relationships in math more quickly. Okay, so and also last lesson we talk about the rules for square roots. So here are some of the important rules that we need to keep in mind when we're dealing with square roots. So we have 4 rules here, and the first one, so we have this the square root of a squared, that's just equal to a. So like if you're going to square a number and take its square root, you'll get the original number back. Okay, so and the second rule, we have the square root of a squared. So that's different from the first one. So this is just the reverse. Like when when taking the square root and squaring it also gives you the original number. And we also have the square root of ab, so it can be equal to the square root of a and the square root of b. Square root of a times the square root of b, rather. So like, yeah, it's like you can separate them, and at the same time we can also separate when we're working on fractions. So like we have we have a fraction in a one big square root. So you can separate the numerator and the denominator to simplify it if if you are if you are working on some harder problems. So like these rules simplify expressions and help us prepare for deeper mathematical operations. So if you want to see and if you want to know um more about this if you want to know more about this um we you can check our chapter 3 lesson 12, so we can have lesson 12, and it's a 20-minute video, so you can like check on that if you want to know. So we have also some examples on these rules on that video, so if you have time you can check on that if you are having trouble with this kind of topic. Now in this lesson we are going to dive on a different topic. So like let's talk about the base 10 system. So like we have here the number system we normally count and calculate as the base of 10. So when we say the base of 10, this is the numbering system that we use every day. So we have tens, hundreds, thousands, 10,000s, so that's the base 10. And quick note, like each of the successive digits of a particular number correspond to that digit multiplied by a certain power of 10. So like we're saying like every digit in the number that has a value based on its position. And each position it represents a certain power. So let's break down with an example. Let's break it down. Like for example, we have 73,520. So we can separate all the digits on that by multiplying it by 10 into some exponent, and we can create its own number. Like so we're like for example we have 7 times 10 to the fourth, because the 7, and when we have 10 to the fourth, that's equal to 10,000 times 7, that is 7,000. So that's like that's just what it is. And you can see the pattern right there, right? So 7 times 10 to raise to the 4, that's 70,000 rather, plus 3,000 plus 500 plus 20, and we're going, if we are going to get the sum of that, that's equal to 73,000. So like each like let's say in simple words, each digit gets its value based on multiplying by a power of 10. So like that's why 7 is in the 10,000 place, because 7 times 10,000, or 7 times 10 raised to 4. So like this is like the structure of what makes like a logarithm, especially the common ones. So like that, it helps us figure out like what power of 10 gives us a certain number. Okay, so before we go, let's have quick notes. So we have some other systems that are not discussed here but are sometimes used, like such as the binary system, which uses um successive powers of 2. So like on that number system you have only zeros and ones, but you can like convert it into like the base 10, like we know. So like the binary system is mostly used on computers, if like on CDs, to store data on it. So it is based on the power of 2, like 2 raised to 1. And but we're not gonna talk about that today because that's a whole different topic. So why do we care? Because we care because the concept of changing bases helps us understand that the same number can be represented depending on what base you are using. Okay? So, it will certainly need to be a positive number since the power of 10 are not normally negative, not even 0. So, like, just keep that in mind, that it needs to be a positive number and yeah. So next, let's have more notes to take notes. So now we can verify what we mean on that with like a calculator, and and if we try, so let's say if we try to get 10 raised to the point 3, so that's equal to 1.995, approximately equal to 1.99526, and 2 is equal to 10 raised to the power of 0.30103. So so what we're saying here, that any number can be approximately equal to is approximately equal to 10 raised to some number. These numbers may seem strange at first, but they show you a core idea of a logarithm. So we're gonna talk that later on. So we're gonna go back on this topic later on. But first, let's talk about the definition of a common logarithm. So in general, when it occurs that x is equal to 10 raised to the y for some positive number x, we say that y is the logarithm to base 10 of x, or the common logarithm of x, and we write y is equal to log base 10 of x. So if you're not seeing any base on a log, that's equal to 10. So keep that in mind. So this is when we have the base of 10 on a log, that's what we call the common logarithm, because it's common, and this is the base that we commonly use in our daily number system. So whenever you see, for example, log x without a base, it's understood to be base 10. For example, if x is equal to 10, then y is equal to 2, because 10 raised to 2 is equal 100. So log 10 of 100 is equal to 2, right? Exponential and logarithm are just like the inverse of it. So let's have a few examples, a few practical examples. For example, first one, log base 10 of 1.99526 is equal to 0.3. So let's have a quick comparison on the previous slide. Let me wait a second. Okay, so let's have our our first slides. So as you can see here, that when we have the log, they have the base 10 raised to 0.3. So let's have 1 second. Okay, so we have here, we have 1.99526. So so the base is the base of the logarithm, and what we have here, and the answer to that is what we're looking. I mean, is uh um the answer to that, and the answer of the logarithm is just the exponent. The answer of a logarithm is just the exponent, okay? Right? Okay. So this is a hard topic to explain, but you can see when we have our second example. Let's have our second example. We have the log 10. 2 is equal to yeah. So like what we have here. So the base is 10 because both bases are 10, and 2 is beside 10 because that's the answer. And if you're going to look for the log base 10 of 2, that is equal to 0. If you're like looking for the exponent, like what exponent do I think that I need to have the answer of 2 with the log base of 10? I with a base of 10. So when we're going, so you're gonna just plug log 10 of 2 on your calculator, and that will give you the approximate answer, which is 0.30103. Okay, so one big example of this is this. So when you have a a log, log base 10 of 1, so that's equal to 0, simply because any number raised to the 0 is 1. So like keep in mind, like if if you have 1 beside the base, like any base, like log 2 of 1, so that's always equal to 0. So when we have 1, that's always equal to 0 because any exponent raised to the 0 is 1. So so it's a very hard topic, but if I mean it's not a very like hard topic. Like if you we study it, you have no problems with it, right? And yeah, so before we close, so like think of a logarithm like a self reflection. Um it tells you what it takes to get from 1 to 10 or from 10 to 100. It's like because it's about understanding your growth journey, like just like you asked, like what power gets me to this number. Like for example, if we consider it in our lives, like what effort, what mindset, or what time will get me through my goal. Like growth isn't constant. I mean, growth isn't instant. Instead, it's exponential. So we're gonna talk about that exponential topic later soon in our series. It's like an exponential. One small consistent push, just like when you increase your exponent like point 0.1, you can double your results over time. So like when you are right now, whether you're in school, you're in work, or you're no, don't be discouraged by where you're not yet. Instead, understand that the power it takes to get there. Like it's like a logarithm. Like you're gonna break it down step by step because everything great starts small. Even a logarithm of 2 begins at 0 point, what we talk about. So so that's it for this video. So I hope you understood this topic, but don't worry if you didn't understood, you can always check, recheck, I mean replay the video if you want to, and you can. And don't worry, we're gonna talk more about logarithms in this series because chapter 4 is all about logarithms. It's a big topic. We have several lessons prepared for that. So so that's it for this lesson, and I'll see you guys next time. Thanks for your attention.